Okay, this video is for section 9.5. We are solving quadratic equations where y equals 0, and we are using the method complete the square. So we first need to review something from chapter 8, which was a perfect square trinomial. There were two special cases in chapter 8. One was the difference of squares, that x minus 9 there, that we factored into x plus 3, x minus 3. The second special case was a perfect square trinomial, and it's where x squared plus 10x plus 25, it factored into one binomial, x plus 5, times itself. That was the part where I would tell you, don't be lazy, be sure you write it out, x plus 5 times x plus 5. So that is a perfect square trinomial. And basically what it means is that last value, c, in this case 25, is a perfect square. And if you take the square root, you double it, multiply it by 2, you get your b value. So you see 25 divided by 2, or sorry, 25, the square root is 5. And if 5 times 2 is 10. So there's a relationship between that c value and its square root and the b value. So basically completing the square, we're going to try to solve by making a perfect square trinomial. And then we're going to use a combination of what we've already learned. We're going to factor and we're going to root both sides. And that's how we're going to solve these quadratics in section 9.5. So first, let's do a quick review here of a perfect square trinomial. So if I have x squared minus 16x plus c, I need to find out what value of c is going to make this a perfect square trinomial. So how could I factor x squared minus 16x plus something into x minus something squared? And I find the value for c by dividing the b value, the middle value, by 2 and then squaring it. So I take my 16, I divide it by 2, I get 8, I square 8, and I get 64. That's going to be my c value that turns that into a perfect square trinomial. So let's do a couple examples like in your homework where we're finding c that will make this a perfect square trinomial. So the first one, x squared minus 16x plus what? So I take that middle term, 16, I divide it by 2, I get 8, I square that, and I get 64. And how that works is then I can factor that into x minus 8 all squared. Okay? Then the next one, x squared plus 18x plus c. What c will let that be a perfect square trinomial? I divide b by 2, I get 9. I square that, I get 81. So I could factor that into x plus 9 squared. Okay? All right. So that is what we discussed in class as far as how we find that c value, how we complete the square. Now let's do one where we're actually solving. So if I have an equation, x squared minus 14x plus 13 equals 0. How can I solve this? I could graph it. I don't want to do that. It might be off the graph. I could root both sides. No, I can't because b doesn't equal 0. I can only root both sides when b equals 0. Can I factor it? Well, in this case, I can. So if this was a problem on a test or a quiz, I would choose to solve this by factoring. And I would factor it just like I did there. What I'm going to do, though, is use this as an example since it's nice, easy answers. I'm going to show you how we would use this complete the square method to solve this particular quadratic. So the first thing when I complete the square, I have to make sure that a equals 1. In this case, it does. If a did not equal 1, like some of the ones in your homework, okay, 25 to 30 in your homework, a doesn't equal 1. The first thing you have to do is divide every one of those terms by a so that a equals 1. That's the first step. The second step is to move any c that's already there to make room for our square, for the square we're going to complete, okay? So if there's a c there like there is here, I need to subtract that 13 from both sides so that I have room for my square that I'm going to complete, okay? So that's steps 1 and 2. Moving around here. All right, now we are looking at x squared minus 14x plus, okay, that was an open square, equals negative 13, because we moved it over, right? So I go to my next line and I say, I'm going to factor this into this perfect square. I'm going to make this a perfect square trinomial, and then I'm going to factor it. So I always have a binomial there. I always have a squared on it. I put x, whatever operation, see there's subtraction there, it repeats into the binomial. Then I take half of b. See that 14? I'm going to take half of it, and I'm going to write that down there. There's my 7. Then I'm going to kind of bounce back up. I'm going to bounce back up to that squared. I'm going to square that 7, and that's 49. That's what I'm going to add to both sides. Okay? Again, this makes a lot of sense if you were in class today. This is kind of a review for you of how we did this in class. Negative 13 plus 49 is 36. So now I have x minus 7 all squared equals 36. I need to get rid of that squared. I'm going to take square root of both sides. I'm going to remember to do positive or negative of the root on the right. And I have x minus 7 equals positive or negative 6. I'm going to solve for x. I'm going to add 7 to both sides. I'm going to get x equals 7 plus or minus 6. So, we set to the side. X equals 7 plus 6, which is 13. Or x equals 7 minus 6, which is 1. So x equals 13 or 1. Those are my zeros. That is the solution to this original quadratic equation. And we can see that's the same answers we got when we factored. All right, next video will be an example.